Today's unit is looking at what's called adding and subtracting rational fractions. And the problem with adding fractions is that we have to have a common denominator. So for those of you who didn't care for adding fractions, subtracting fractions, just normal numbers, this could be kind of difficult. But we'll try to walk through it and hopefully it's going to make some sense for you. All right, one thing I want you to always remember is that when you're adding fractions, one fraction plus another fraction will give you an answer that is a fraction. So there is nothing in this unit that says that when you're done, you're going to be left with something that might say, x equals 7. We are not solving equations. You are just adding fractions together. One fraction plus another fraction must give you a fraction for an answer. The way we're going to do this is to build up each fraction by multiplying by the piece that is missing. So what does that mean? Well, if we look at this first one, 3 over 4x minus 1 over 7, these are not the same denominators, so I cannot add these fractions as they stand. I need to get a common denominator. So I need to figure out what do they both multiply up to go into. So if I look at it in pieces, 4 and 7 have what in common? What do they both build up to go into? That would both be 28. So I know I'm going to have at least 28 in my denominator, and I have an x here, so every time I see an x, I have to use the x. So I'm thinking that my common denominator is going to be 28x. So if I rewrite this fraction as something over 28x and something over 28x, then I need to do this part. I need to do the build up part. If I started my first fraction as 4x and I need to build it up, in other words, multiply by something to give me 28x, what would I need to multiply by? I would have to multiply by 7. So I need to do that multiplying in both the top and the bottom. My new top will now say 21 over 28x. And when I move to the second fraction, I started with 7 and I need to multiply up to give me 28x. I will have to multiply by both 4 and an x, and then I need to do that in the top as well. 1 times 4x gives me 4x, and then 7 times 4x gives me the 28x that I need. Now I have a common denominator. I can write that down one time, and then I can just do the subtraction on the top. 21 minus 4x. Those are not like terms, so they're just going to sit next to each other. The last thing we always want to try to look for is, can I reduce in all three places? 21, 4, and 28 all have to have something in common in order for me to reduce. Remember, you cannot cancel parts of terms. I cannot reduce the 21 and the 28, knowing that 7 goes into both of those. I cannot do that because 7 does not also go into 4. So this would be your completed answer right there. Okay. When you have something like number 2, 1 over 3x squared plus x over 9x squared minus 12x, when you have pieces in the denominator that are quantities, 2 terms or 3 terms, you must factor the bottoms first. That's going to help you decide your common denominator. When I look at 9x squared minus 12x, I can take out a 3x. I'm left with 3x minus 4. On the other side, I've got a 3x, and then I'm just going to separate that with a plain x as well. So 3x times x, that's my 3x squared. Now I need to pick out my common denominator. Anytime you see something in parentheses, you're going to be using that for sure as part of your common denominator, 3x minus 4. I've got a 3x and a matching 3x in both fractions. I'm going to use that matching piece one time, and then if I have anything left over, I need to use that as well. I have this 1x left over, I will need to use that as well. So my whole thing, common denominator, will be 3x squared and the quantity of 3x minus 4. So I'll rewrite this question, something over 3x squared, 3x minus 4, plus something over 3x squared, 3x minus 4. Now I need to do my comparing. In the first fraction, I have 3x squared. I need it to be 3x squared and the 3x minus 4. So what's missing? What could I multiply this first one by to come up with this second one? Well, the only thing that's missing is the quantity of 3x minus 4. So that's what I need to multiply by in both the top and the bottom to give me my new bottom, 3x minus 4 times 3x squared. So on my top, 3x minus 4 times 1 is just that, 3x minus 4. I move to the second fraction and look to see how it started. It started as 3x times 3x minus 4, but I need it to say 3x squared times 3x minus 4. Can you tell what the only piece is that's missing from the first one to the second one? The only piece that's missing is that one extra x. So that's what I need to multiply by in the bottom, and the top is that one extra x. My new top will now be x squared, and then the bottom, of course, is 3x squared times 3x minus 4. Now I have a common denominator. I can go ahead and do the addition on this one. I have 3x minus 4 plus x squared. None of these are like terms, so they're all just going to sit next to each other. I'm going to write this in descending order. X squared plus 3x minus 4. Our next one is a trinomial in the first denominator and a binomial in the second denominator. So again, we always want to factor first. First one factors into x minus 4, x plus 3. Second one factors into 12, x minus 4. So now I need to pick out my common denominator. This common denominator, by the way, is called the least common multiple. I see the quantity of x minus 4 in both of them, so I have to use x minus 4. And we only use it one time. I've got another quantity of x plus 3. I have to use every quantity that I see, so I will be using the x plus 3. And the only thing that I haven't used yet is the 12, so I have to use the 12. So this entire piece of 12, x minus 4, and x plus 3 is my common denominator for these two fractions. Now I look for missing pieces. What is missing from the first fraction? So to get from x minus 4, x plus 3 into 12, x minus 4, x plus 3, what's the only thing that's missing? 12. So I need to multiply the first fraction by 12, top and bottom. That gives me a new top of 12x. Now move to the second fraction. It started out as 12x minus 4, but when I build it up, it becomes 12x minus 4, x plus 3. What's the only thing that's missing here is the x plus 3. When I do the distribution on the top, this new fraction top becomes 5x plus 15 over 12x minus 4, x plus 3. Now I have my common denominator. Now I can go ahead and add all the way across the top. I do have like terms here, 12x plus 5x, 17x plus 15 over 12x minus 4, x plus 3. 17x plus 15 does not reduce, it doesn't factor, so there's nothing else I can do with this to make it any simpler. The next one, 3 over 10x squared plus 2x over 5x squared minus 10x. I'll start by factoring this second one. We'll take out a 5x, that's going to leave me with x minus 2. The second one is 10x squared. So if I think about 10x squared, and I know that 5 actually goes into 10, I just want to rewrite this. It might make it look a little easier as 5x times 2x. You all agree that that would give me my 10x squared. So now I want to pick out the things that are common in order to make my denominator. I do not have a matching x minus 2 in both of them, but I know that I need to use every quantity that I see, so I have to use the x minus 2. I do have a 5x that matches in both of them, so I can just keep that 5x one time, And then I look for anything left over that I also have to use. That would be the 2x piece. So my entire least common multiple, also known as common denominator, will be 10x squared times x minus 2. Let's rewrite our fraction. Something over 10x squared x minus 2 plus something over 10x squared x minus 2. And now I look for missing pieces. In the first fraction, I started with the 10x squared. I need it to be 10x squared times x minus 2. The piece that's missing is the quantity, x minus 2. So that's what I would need to multiply by, which gives me with the distribution 3x minus 6. In the second one, I have 5x with the x minus 2. I'm supposed to have 10x squared with the x minus 2. So the only piece that's missing is how I get from 5x to 10x squared. That's the 2x. That's that extra 2x that I need. So I'll have to multiply by 2x on both the top and the bottom. That gives me 4x squared up here, and then the required 10x squared, x minus 2 in the bottom. Now again, I have my like terms. I can go ahead and add all the way across, and I'll put this in descending order again. 4x squared plus 3x minus 6 over 10x squared x minus 2. Have you noticed that in every one of these fractions that we've done, we started by adding two fractions and our answer is another great big fraction? That will always happen when you're doing these. You will always end up with a fraction. Complex fractions. When you add, or simplify complex fractions, we cannot have, and we've done this before, you are not allowed to have baby fractions inside of a big fraction. That breaks the whole fraction rule. So we have to do something to get rid of these little baby fractions. So what I want to do is concentrate on the original denominators for the little baby fractions. 6, 3, 5, 10. I need to think about one number that all four of those will go into evenly. 30 is the value that I'm going to look for. 30 is a number that all of these, 6, 3, 5, and 10, will go into evenly. So the way we get rid of these little baby fractions, and this right here is our main dividing line. What I'm going to do is multiply the entire top by 30 and the entire bottom by 30. Now, do you all agree that if I were to cover up the original fraction piece, I'm left with 30 over 30, and that's just a form of 1? I can multiply anything I want by a form of 1. 30 over 30 would qualify for that. And I picked 30 because that's what I decided my common denominator would be. So now what we do is a distribution on the top twice and a distribution on the bottom twice. That will allow me to reduce this little baby fraction. 30 times x, but I'm dividing by 6. 30 divided by 6 leaves me with 5x. Second distribution, 30 times x, but I'm dividing by 3. 30 divided by 3 would be a 10. So that new top, no more baby fractions, is 5x minus 10x. Moving to the denominator, 30 times x, but I'm dividing out the 5, leaves me with 6x. And then 30 times 7, but I'm dividing out the 10. Again, 30 dividing out the 10 is 3, so I really only have 3 times 7, 21. My top, original top, is now something that can combine 5x minus 10x, and the bottom will stay. Negative 5x over 6x minus 21. This next one is fairly simple. We've got one whole number on the top, which is really 4 over 1. The little fraction on the bottom is 3 over 1. So of the 4 baby fractions, the only denominators that I really need to worry about are x. And it's a matching x in both of these, which means my common denominator is just x. So I will write one great big multiply by, I'm going to put my big divide line in here, 1 multiplied by x on the top, 1 multiplied by x on the bottom. And now I can start with my distribution. X times 2, but divide out the x. That leaves me with just 2. X times 4, and I'm dividing by 1, so nothing has to cancel. I'm left with minus 4x. No baby fractions left on the top. X times 2, but divide out the x, leaves me with 2. And x times 3 is 3x. There's nothing in here that can factor, nothing that will reduce. So this is the answer. 2 minus 4x over 2 plus 3x. All right, here's our last one. We've got one great big complex fraction with 3 baby fractions inside. The baby fractions have denominators of x plus 5 and an x minus 3. I need to use both of those as my entire common denominator. So I'm going to highlight again my big divide line. So once on the top, I'm going to multiply by my denominator of x plus 5, x minus 3. And then once in the bottom, same thing, x plus 5, x minus 3. Now remember, when we do our distribution, something will cancel, so we will rid ourselves of the little baby fractions. X plus 5, x minus 3 times the 3, but we're dividing out the x plus 5, which means the only thing I really have left is the x minus 3 times the 3. 3x minus 9 on that distribution. Next one. X plus 5 times x minus 3 times 2, but then I'm going to divide out the x minus 3's. So the x minus 3 would disappear, leaving me with just 2 times the x plus 5. And then in the second one, x plus 5, x minus 3 times 1, but this time we're going to divide out the x plus 5. I'll use a different color. When we divide out the x plus 5, that's going to leave me with just the x minus 3 times 1 as the distribution. So it's just the plus x minus 3. All right, let's clean this up just a little bit. We had 3x minus 9 on the top. Distribution here, 2x plus 10 plus x minus 3. 3x minus 9 over, like terms, 2x plus 1x. There's 3x. And 10 minus 3, 7. 3x minus 9 over 3x plus 7. Now remember, you cannot cancel these 3's. 3x minus 9 is one entire quantity. You can't take pieces of quantity unless you have something matching in the bottom. So that would be your answer right there. 3x minus 9 over 3x plus 7. I believe that was your last one. Correct. All right, so biggest thing with these is looking for your common denominator. Start with the fraction. You're going to end up with the fraction for an answer. And remember, it's all about building up to make your common denominator. Good luck.